Second part for this chapter 14, just highlighting the most important key point, naming alcohol, where another thing we have to go over is the way we classify them as primary, secondary, or tertiary alcohol. This has to do with the number of carbon substituent bonded to that hydroxyl OH carbon. So right here on the far left, you see I have one OH that is connected to a carbon atom with a covalent bond, and then you have two hydrogen atoms with covalent bond, and it's attached to one R group. R is any other organic compound, primary alcohol. When you have R and R prime, that means it's a secondary alcohol. When you have R, R prime, R second, and only one covalent bond that links to the hydroxyl bearing carbon, it's a tertiary alcohol. How do we name those? Well, same thing. You are going to first look at here systematic name of the compound below. How do we do this? Well, first you find, as usual, the longest carbon chain, number the carbon atom when you start at the end that is the nearest to the hydroxyl OH. Here we look at 1, 2, 3, 4, 5 carbon atom. So that will be a pentanol. Then we're going to look at here, well, what type of substituent we do have. So this is here the hydroxyl we have. We have a methyl in number 2. So that's going to be a 2-methyl 2-pentanol. Okay? Now, what kind of alcohol is that? Is it a primary, secondary, or tertiary? Well, I only have one OH. On the top of my carbon, I have a CH3. On the second bottom, I have a CH3. On the far left, I have 1, 2, 3 carbon atoms. So this is a tertiary alcohol. Other example I would like you to start and work on is example 14.2. Draw the structure of 2,3-dimethyl-2-butanol and then 3-ethyl-cyclopentanol, and be able to classify them primary, secondary, or tertiary. So what we're going to go, well, same thing. Start with the longest carbon chain, number the carbon atom, and give them in an order where the index number is given for the OH group, which is the lowest number. Now when you see right here, if it's a butanol, it has 4 carbon atoms, 1, 2, 3, 4. If it's a 2-butanol, that means the OH group is attached or bonded to the carbon number 2, and the methyl groups have to be bonded to carbon 2 and 3. So this is how you can draw them. So when you look at here and try to fill out the remaining hydrogen, what it gives here, left side condensed formula, right side line structure, the 2,3-dimethyl-2-butanol. Now, if you look at here, the bonding, where you have one OH that is attached to a carbon atom with a covalent bond, and it has 3 other carbons that are bonded to it, so this is a tertiary alcohol. We look at the other one, the one we were talking about. Here I have a ring, 1, 2, 3, 4, 5, OH on number 1. We do know it's on number 1 because it's definition. Lowest number for the substituent, which is an ethyl, and this is going to be the name that you have right there. Alcohol are very important because they can be used for many other organic molecules. I will go over some of the most important reactions, such as dehydration and also some oxidation. So dehydration, when you feel dehydrated, that means that your body is lacking water. So that means that the molecule of alcohol will go under a loss of water. And that happens with a very strong acid here, sulfuric acid. You see here on the left side that alcohol is going to lose one OH and one hydrogen from the CH3 that you have on the far right side. And I give you here Well, a double bond which becomes a 2-methylpropene and the H2O. So you see this on the product, but that H2O, which is the water molecule, is lost to the system, so the dehydration. Sometimes you have more than one alkene that can be the end product, and most of the time you have a mixture of the product that is formed. The major product has the greater number of alkyl group directly attached to the double bond carbon. This is close to the Markov-Nikov rule we went over, so just review this. Pretty much 80% of 2-butene and only 20% of the 1-butene. Reason you have on the left side 2 alkyl group on double bond carbons versus 1 alkyl group, which is the CH2CH3 on the 1 double bond carbon. Things you need to know: I will not ask you those reactions, but I will ask you a question about how do primary alcohol react? How do secondary alcohol react? So primary alcohol are converted into aldehyde. Sometimes they can go under carboxylic acid if you actually add an excess of oxidant. That's the example. Secondary alcohols are converted into ketone, and that's what we use for some of the tests. We'll talk about those later. And then tertiary alcohol, they can't actually have any reaction with oxidizing agent because they don't have one extra hydrogen on the carbon atom where you have the hydroxyl OH that is bonded, so there is no reaction. And then finally, one thing I want to say about phenol, where phenol is the name for both a specific compound, hydroxybenzene, so that's the formula, as a family of compound we're going to just look at on the next part of that presentation. Most of the time we use here the ending phenol instead of benzene. I already mentioned this, so those are examples. I will not ask you about the O or the P, but chlorophenol, just know they exist, or methylphenol, know they exist. That's the end of part number 2.